Hi everyone. Today we are going to discuss about theorem in functions chapter. So this is one theorem. So what is the statement of the theorem? If f function, that means if f maps a to b and g maps b to c are two 1 and onto functions, then G circle f or GOF maps A to C is also 1 and onto we need to prove. Okay, so they are asking us, they given two functions, they given f function and g function. These two functions are already 1 functions and onto functions. So they are asking us to prove whether this GOF A to C is also 1 and onto or not. So for that, first we will prove, first of all, this GOF is 1 function or not. Next we will prove this GOF is onto function or not. Okay, so first, in order to prove GOF is 1 function or not, so this is the process. Okay, in order to prove that, which is there in your textbook. So I am going to explain step by step. Okay, so see here. So let x1 comma x2 belongs to A. That means suppose if you have a set, okay, if you have a set which is named A, this set A, when you are representing through oval shape, this one is called domain. Okay, this one is called domain. Why? Because the given one function f maps A to B. So we are going to draw a set which is called domain. This is called domain, this is called codomain. It is a function which is mapping from domain to codomain. So I will draw one codomain, that is B. Okay, there is one function which is mapping from domain to codomain. Okay, which is mapping from domain to codomain. There are some elements here which are mapping to certain elements in codomain. What are those elements which are there in X, which are there in A, are x1 and x2. Okay, these are the two elements which are there in domain A set. So here what are the elements are there? Here there are the elements f of x1 and f of x2. These are the two elements which are mapped like this. X1 is mapped to f of x1 and x2 is mapped to f of x2, which are there in B. x1 and x2 are there in A. So now if you carefully observe the first line, they given x1 comma x2 belongs to A. So x1 and x2 belongs to A. Okay, so GOF of x1 equal to GOF of x2. This one we are assuming. Let means what? We are assuming that x1 and x2 belongs to A, and GOF of x1, GOF of x2 both are equal. Why? Because we know that if the function is 1 then definitely GOF of x1 equal to GOF of x2. That implies at the end we need to get x1 equal to x2. So if you are assuming this condition, at the end you should prove that x1 equal to x2. Then we can say that GOF is 1 function. So we will try to prove by taking this condition. That means this one we will assume and we will try to prove x1 equal to x2. If we are able to prove x1 equal to x2, then automatically GOF is a 1 function or not. So that's why we are assuming this GOF of x1 is equal to GOF of x2. Okay, so this is the first line. Next line you see, x1 comma x2 belongs to A. They given one function, right? F maps A to B is the function which they given. Okay, if f maps A to B is the function, that implies that f of x1, f of x2 belongs to B or not. So here we are taking x1 and x2 belongs to A. F is a function, that implies compulsory f of x1 and f of x2 belongs to B. Okay, so this is what the condition they given, that we are assuming. Clear? Next, this one we are assuming, right? GOF of x1 is equal to GOF of x2. So we can write like this. Whenever if you remove circle, we can keep square bracket. So that's why GOF of x1 can be written as what? G of f of x1. That should be equal to G of f of x2, right? But f maps A to B is 1 function. they only given in the question that f maps a to b is a 1 1 function. If it is a 1 1 function, then this condition should satisfy, right? We can write like this. That means whenever a function f maps a to b is a 1 1 function, you can write f of x1 is equal to f of x2. Okay, then x1 equal to x2 or not. Okay, actually we will prove in reverse. Suppose if f maps a to b is a 1 1 function, we will take x1 equal to x2 and we will prove that implies that f of x1 equal to f of x2. Anyway both are same or not. So since f is a 1 1 function, f maps a to b is a 1 1 function, that implies f of x1 equal to f of x2, then x1 equal to x2. That means overall what you have to remember, f maps a to b is a 1 1 function, so that's why instead of f of x1 f of x2, simply I can write x1 equal to x2. Okay, so that's why instead of f of x1 I have written x1, instead of f of x2 I have written x2. Okay, because f is a 1 1 function, you can write like this. But similarly g is also a 1 1 function. They only given in the question that g is also 1 1 function. If g is also 1 1 function, instead of g of x1 I can write x1, instead of g of x2 I can write x2, right? Both are equal, so instead of g of x1 g of x2 I am writing x1 equal to x2. Okay, so now if you carefully observe, we came to a conclusion that x1 equal to x2. We have assumed graph of x1 is equal to graph of x2, and we came to a conclusion x1 equal to x2. That means graph is also 1 1 function or not, right? Because here you see f of x1 equal to f of x2 means we got x1 equal to x2. This is the condition for 1 1 function. Similarly here also g maps b to c is also a 1 1 function. Similarly here also we assumed graph of x1 equal to graph of x2, and we got x1 equal to x2. Okay, so that's why graph is 1 1 function. So we can write x1 comma x2 belongs to a, graph of x1 is equals to graph of x2. We assumed this and we proved this, x1 equal to x2. So that's why graph is 1 1 function. Understood? So that's why graph is 1 1 function. And here also you can see for each element in domain we only have one mapped element in codomain. So that's why it is 1 to 1 function. Okay, it is also one element in A set, it is mapped only to one element in B set. So that's why it is called 1 1 function. Okay, so graph is 1 1 function. So here you understood, right? So graph is 1 1 function. Similarly we need to prove graph is onto function. If you prove graph is onto function, then automatically graph will be bijection. So for that, in order to prove graph is onto function, what I am assuming one element in C. Okay, now you see, now I am considering g function. If you consider g function, in question they given clearly g function is mapping from where to where, g maps b to c. So now g is mapping from b to c. This is g function which is mapping from b to c. That means this b now it will become domain. This c is nothing but codomain or not. This c is nothing but codomain here. Okay, now here there is one element. Here there is one element called z. So z belongs to c. If z belongs to c, okay, and they given g is an onto function. If g is an onto function, compulsory here one element should be there or not. Whenever one element, that element I am assuming it as y. Okay, so y is mapped to this z. Okay, so similarly here also one function we have. Here if you keep a, now this one will become domain, this one will become codomain or not, right? So here which function is mapped? Here f is the function which is mapped. So if f is function which is mapped to a to b, then here should also one element should be there. That element I am assuming it as x or x1 or x2. In this case we assume, right? So here also we are assuming x. Understood? So listen carefully. We are coming from reverse for proving onto function. So first we will assume that G maps B to C is onto function. If G maps B to C is onto function, this one will become domain, this one will become codomain. So in codomain we are assuming one element is there. That element is Z. Okay, Z belongs to C. If Z belongs to C, now you observe, if Z belongs to C, they given clearly. If Z belongs to C, in question they given that G maps B to C is onto function. If G maps B to C is onto function, that implies there exist y belongs to B such that G of y is equal to Z. What is the meaning of this? Whenever you have one element in C, compulsory one element should be there in B. Okay, that element is y. Okay, that is the information which they are giving from the onto function. If you have an onto function, if one element is there in C, compulsory one element should be there in this section also. Okay, so we have one element in Z which belongs to C, so compulsory one element of y will be there in B. Okay, so that's why we can write G of y is equal to Z, right? So that's why we have written here G of y is equal to Z. Similarly, suppose if one element is there in y, compulsory one element should be there in A. Why? Because the given f maps A to B is also onto function. Okay, so here you can write here you see, if y is there in B, compulsory one element should be there in A which is mapping to this y. Okay, so that's why we can write f of x is equal to y, just like what we have written here. G of y is equals to Z we have written, right? Similarly, you can write f of x is equals to y. Okay, so that's why here we have written y belongs to B. Whenever f maps A to B is onto function, that implies there exists x belongs to A such that f of x is equals to y. Okay, whenever G and f are onto functions, you can write like this: G of y is equals to Z, f of x is equals to y. Okay, now again we are assuming this condition just like what we have assumed in 1 function. Okay, so G circle f of x we are assuming. So G circle f of x means what? Already f of x means what? F of x means just now we got, in place of f of x you can write y. So that's why in place of f of x I am writing y. And already I know G of y is what? G of y means just now we got z. So that's why I have written z here. Okay, so now if you carefully observe what you got, graph of x is equals to z you got. Okay, graph of x is equals to z. That means what is the conclusion of that? Z belongs to C. Okay, Z belongs to C. That implies there exists x belongs to A such that graph of x is equal to z or not. We got this relation, graph of x is equals to z we got. Suppose if you have f of x is equals to y, what is the meaning of this? X belongs to A, y belongs to B. G of y equal to z means what? Y belongs to B, z belongs to C. Similarly, we got graph of x is equal to z. That means what? X belongs to A, no, and z belongs to C, no. So directly we got a relation from directly from A to C. Okay, this is that relation. Okay, so graph of x equal to z, meaning is what? That means compulsory z belongs to C. If z is there in C, compulsory there should be one element in A. That element is nothing but x, such that what is the relation between them? Graph of x should be equal to z. We got this relation. If we got this relation, then we can assume graph maps A to C is onto function. Okay, why? Because here you see, if G maps B to C is onto function, you can write G of y is equals to z. Then reverse. Suppose if f of x is equals to y, then you can write f maps A to B is onto function. Okay,
So in the similar lines, if gof of x is equals to z, then gof of a maps c is also onto function. Okay, what is the meaning of this? Compulsory, whenever one element is there in z, this element should be mapped to any of the element which is there in a. Okay, now it is mapped. One element in a, that is x, is mapped to one element in c, that is z. Gof of x is equals to z, so gof is onto function. Understood? And one more condition is what? One more condition is range should be equal to codomain. Okay, then only we can say that any function is onto function. Range should be equal to codomain. Now if you carefully observe here, okay, if you carefully observe here, how many elements are there in this C codomain? Only one element. This one element is mapped to this y or not. That means this y is mapped to this z. That means here codomain, number of elements in the codomain is 1. Okay, range means what? Range means how many elements are mapped. Okay, how many elements are mapped in this codomain? We only have one element in codomain, and that one element is also mapped. Okay, so codomain elements are how many? Codomain elements are 1, and mapped elements are how many in the same codomain? Mapped elements are also equal to 1. This mapped elements is nothing but range. Okay, mapped elements is nothing but range. So here codomain is equal to 1 and range is also equal to 1. Then we can say that this g is onto function. Similarly, here also if you will observe, codomain element is only 1 and it is also mapped. That means range is also equal to 1. So that's why f is onto function. Okay, so if you observe directly from x, that means from a to c, x is mapped to z. Again here also codomain element is 1 and range is also equal to 1. So that's why gof is gof g maps g circle f maps a to c. Okay, g circle f maps a to c is also onto function. So simply you can remember like this. Suppose f maps a to b is 1 and onto function, g maps b to c is also 1 and onto function. Then like this you have to remember. Okay, g circle f maps a to c. Okay, g circle f maps a to c is also 1 and onto function. Okay, so that only we proved here. Okay, first we proved gof is 1 function, next we proved gof is onto function. Okay, if you write this, it is more than enough. Okay, just for this theorem, if you write this total data, then it is more than enough. I hope you got clarity of what to write whenever this theorem is given. Okay, this thing you have to write. Clear? So if you have any doubts in this theorem, please comment me. Thank you.